Question number 14. Find the smallest positive integer n which is at least 10 such that n plus 6 is prime and 9n plus 7 is a perfect square. It is given that n is at least 10, so we get n plus 6 is at least 16 and this is a prime number. Any prime which is at least 16 has to be odd. So we have n plus 6 is odd or n is odd. So let n be equal to 2k1 plus 1 where k1 is an integer. 9n plus 7 is given to be perfect square, so let's call it m square. From here let's take n is equal to 2k plus 1. We get 9 into 2k1 plus 1 plus 7 is equal to m square, or 18k1 plus 16 is equal to m square, or 18k1 is equal to m square minus 16, or 18k1 is equal to m minus 4 into m plus 4. Here the left hand side is even, so the right hand side also should be even. Therefore m has to be even. Let m be equal to some 2k2. Substitute this in the above equation. We get 18k1 equals 2k2 minus 4 into 2k2 plus 4. Upon simplification we get 9k1 is equal to 2 into k2 minus 2 into k2 plus 2. Now the right hand side is even, so the left hand side should be even. So let us denote k1 by some 2 into k3. Upon substituting this in the previous equation we get 18k3 is equal to 2 into k2 minus 2 into k2 plus 2, or 9k3 is equal to k2 minus 2 into k2 plus 2. Now here the left hand side is a multiple of 9, so the right hand side also should be a multiple of 9. This can happen in two ways. Either one of these two numbers should be a multiple of 9 or both should be a multiple of 3. Now both cannot be a multiple of 3 because they differ by 4, so one of them should be a multiple of 9. So we get k2 minus 2 is equal to some multiple of 9, or k2 plus 2 is equal to some multiple of 9. In other words, k2 has to be of the form 9k4 plus 2 or 9k4 minus 2. So we have a few results: n in terms of k1, m in terms of k2, k1 in terms of k3, and k2 in terms of k4. Let's put k4 is equal to 1. We get k2 is equal to 9 plus 2 11, or 9 minus 2 7. And using this, let us find m value. We get m is equal to, m is 2k2, so m is 22 or 14. Now we have n in terms of m from here. We get n is equal to m square minus 7 by 9 from this equation. So if we substitute 22 or 14, we get 22 square minus 7 by 9, or 14 square minus 7 by 9. 22 square is 484, 14 square is 196. So 484 minus 7 would be 477. This would be 189. So we get n equals 477 by 9 would be 53. 189 by 9 is 21. Here we have n plus 6 as prime number. So if n is 53, n plus 6 would be 59. If n is 21, n plus 6 would be 27. This has to be a prime number. 27 is not a prime, but 59 is a prime. So we get n plus 6 to be 59. Therefore, the smallest value of n is 53, and that's the answer.